For instance, I want to remove the seismic parameters. How you remove the seismic parameters? You need to come to these provisions of project parameters, click right there, and then click on this provision here. Once you click here, see the seismic option is being removed. So if you check here, it is still here. Once I click on OK options, you will see seismic parameters tab here again. So I do that right away. Click on OK options, just like this. You can see seismic parameter tab has been removed from here. All right. Okay. So if I come to project parameters again, all right, and then I click in these three dotted provisions, if you take me to the project, I'll be able to choose IBC, which is the International Building Code, this one for the seismic. Okay, click on picked options. The picked it is now there. So once I click on OK, you will see it appears here. So this is how to navigate or to turn on and off seismic provisions in this project analysis dialog successfully. Click on OK so you can see it right there. Hello friends, I'm Soft Reason. You are very welcome to this presentation. In this presentation, I will be sharing my experience during the course of designing this massive hotel structure. This structure was built on an earthquake fault line. And also, I will be showing us how to apply earthquake load on this structure successfully. In addition, I will be taking us through on how you can use this template to carry out any design at all you want to do using ACI code, because this design was carried out using ACI code successfully. Once again, you are very welcome, and do not forget to like and subscribe to this channel. Let us straight away dive into the lesson. At first, I will be taking us to AutoCAD, so you will actually take an overview of the elevations and the plan of this massive hotel building. So here in AutoCAD, I have the elevation of the structure, just like this. Okay. And for the plan, here is the plan of this structure. Okay, so let's get back to Protastructure. So if you observe very well, you will notice by this phase of this structure, I have up to 13 stories. Okay, and as also this phase, I have up to 8 stories, and this other phase are 16 stories. So I divide the structure into phase by phase. So if I should navigate to the plan view of story 1, so you will actually have this. Okay, each of the phase, just as I separated it with a construction joint, so you can see it here. All right. Okay, so if I should go back to the 3D right there, and I'm having this, it is not always good to carry out a massive structure like this in Protastructure in full length as it is. Okay, because the load applications may not necessarily be able to be distributed all over the structure, basically the earthquake load. The ugly experience I have during this design is after having modeled this structure just like this, an earthquake load was applied to it. I noticed most of the members are giving me some sections that are not really good, like very large sections of the columns, very large sections of the beams. And so I have to contact Protastructure team, and then they actually advised me not to carry out this structure modeling massively just the way it is. I should model it segment by segment. So the same advice I want to transfer to us right away. If you have a structure of this kind to design in Protastructure, do not model all of the structure just like this. Okay, you can't just model a segment by segment. For instance, you can take this first segment, you can see a joint here. All right, so you can cut out this particular segment through these directions and then model it as a single structure. Divide all of this into an individual structures and do the analysis. Apply your load first, do the analysis, and as well as design successfully. Let it be individual. Individual in the sense that where you have this expansion joint, you just take all of this structure, take all of this one as a single or individual structure, carry out your loading, analysis, and design successfully. After which you can now have to look at this face, okay? After which you look at this face, all right? Then just continuously like that, face by face, analysis and design. Do not analyze this structure the way it is, because you will not get the result you actually wanted due to failure in the proper distributions of load to the structure successfully. Okay, so if I should navigate to the analysis tab right there, and then I go to the building analysis. In the building analysis dialog, just like this, and then you can see the seismic parameters right there is actually enabled. And we go straight away to the project parameters. In the project parameters, you can see the concrete design code is the ACI 318, okay, United States. Okay, so the state design code is the AIXC 360. Okay, so this is an ACI code. The earthquake code is IBC United States. All right, so this template is actually set for ACI code design. So if you actually want to be using this template, I will leave a link in the description of this video so you can actually get this template and be using it for your ACI design successfully. And I'll be taking you through how you can use it effectively just a minute. Okay, so if maybe you want to design a structure, you wouldn't want to use an earthquake, but you want to use ACI codes, okay, for your design. What you need to do is just have to click on this particular provisions where my cursor is. If you click here, this earthquake will be removed. You will no longer see it right here. Okay, but I will navigate back to ensure that I remove it to show you an example successfully. But for now, I will leave it because I will demonstrate how to apply earthquake to this structure successfully. Okay, so before you should apply an earthquake to this structure, you have to first of all enable it here. You make sure earthquake code is enabled here. Okay, so once it is enabled here, you found it here as well. Okay, in the building analysis dialog right there successfully. Okay, for the foundations, the soil stress is 100 kilonewton per square meters. Okay, so the detail of the project is just like this. Okay, right, this project was carried out by this company successfully. So I click on OK to get right up here. All right, so if I should come all the way to the seismic parameters tab, click right there, and here is the seismic IBC seismic parameters dialog. Okay, so in this IBC seismic parameter dialog, under parameter tab, so there are some important changes you need to make with respect to the geotechnical reports of the area. Just as I said earlier, the structures was constructed on the earthquake fault line successfully. Okay, so what you should be looking at is the spectral accelerations and soil factors successfully. If I should enable the soil report of this site, you will have something of this kind. Okay, so this is the soil report. You can see this one. So when you're talking about the spectral accelerations and soil factors, it's been taken successfully, the seismic parameters and site class value. Okay, so what you just need to change in this particular provisions, you should be actually looking at the X subscript 1 and then X subscript X. All right, so these are the spectral accelerations options. Okay, so if you check here in the parameter tab, what we have here, you can see X subscript X, which is the same thing we have in the soil report right here, X subscript X. So you have to make sure you feed in this value. This is the first row there for the 100% in 50 years. Sorry, 10% in 50 years. You are having it to be 0.52. So you replace that here. So you can see it here. 0.52 is being replaced or imputed right there. Okay, for the X subscript 1, you have it to be 0.22. So you have to just feed in that. Very, very important. So this is how you can actually apply the spectral accelerations and soil factors successfully. And also, if you check through the if you check through the soil report, you can see the site classes. Okay, based on the calculations and local geology, the site has been classified as site class D, firm soil, site class E, soft soil. So you must take note of all of this. Okay, so when you want to carry out, whenever you want to carry out an earthquake structure, okay, design, an earthquake structural design, you have to make sure you are reading in line with the geotechnical informations of the construction site. Very, very important. So you can see here we have classed site classed here, and also over here in the report says that the site class which you used is site classed. We have site class D, okay, site class D for firm, and site class E for soft soil. So we are going to be considering site class C, which is the soft soil. That's why you see it's being selected here. So if I click in this provisions now, you can see you will be able to select various site classes. Okay, site class A is for hard rock, B is for rock, and C is for hard soil, very solid soil and soft rock. Okay, D is medium soil. Okay, E is soft soil. All right, so you select C and then click on the OK options successfully, just like this. Okay, and the structural parameters like the risk category, if you click right there, you can be able to read the how the structure is being exposed, whether it is exposed to an atmospheric conditions or that is not favorable. Okay, so this have to be selected successfully, and it is called risk category, and as well you can see the description of the risks. So depending on the site of constructions. So in the case of this structure, I selected this risk category 3, okay, and which is building and other structures, failures of which could cause a substantial risk to the human life. You have to select this. So all of this contribute to the loadings of the structure in terms of earthquake successfully. Click on the OK options, just like this. So majorly the changes actually take place in the parameters tab. In the analysis tab, you don't have any more changes here. You can just leave this at default. And then the structural and the irregularities, all of this can be at default. Also in the settings, okay, all of this can also leave them at default. But in the parameters, okay, you have to make sure the spectral accelerations and soil factors is being changed. The site class is being also changed. Structural parameter like risk category is being selected successfully. Okay, and once you are making the selections, you can also observe the changes in the graph. Okay, the display elastic spectrum graph right here. You can actually observe the movement of the graph, after which you just have to click on the OK options, just like this. Okay, so once you OK that, it simply means the loads has been applied successfully on the structure. But just as I said earlier, you shouldn't carry out a massive modeling like this in Protastructure, because you will not get the results. You will not get it right at all. The sections that will be selected for you will be quite large, that you will even be confused. So you have to segment the structure, cut it part by part, and design part by part successfully. That is the right way to get right result of your analysis and design successfully. Okay, so if the same thing applicable to wing loading. Okay, if you click in this wing loading combinations, so all the combinations are being selected just like this. Okay, click on the OK options. So the wing and story loads, if you click right there, in that tab you will have story parameters and load dialog, just like this. You just have to click on the wing load calculator right there. So once you select the wing load calculator, you will be having a wing load calculator dialog, just like this. In this provision, what you just need to apply there is the basic wind speed. Very, very important. Okay, the risk category, you have to also select it here if it is exposed directly to the air, or there are some trees around the structures. This is where you can be able to select your category successfully. Okay, but the basic wind speed must be applied and successfully. Okay, also come to the terrains and surroundings, enclosed classifications. All right, enclosed building. So you have to actually carry out the survey of the site to be able to gather all of these informations. Exposed category, exposed B is what I choose in this design. Okay, so if you read the information there, you have the options of choosing any exposure option. Okay, for the sake of this structure is exposure category B that I selected. Okay, surface roughness. Okay, so you have to also check this out. Once you read through all of this, you can be able to select the right roughness category successfully as well. So with the rest of these, you just have to go through them successfully and then be able to choose the right options. Okay, after which you can choose to create a report for your wind load applications. Okay, once you click here, a report will be created for you. Click on apply it. All right, and okay, it will be calculated effectively and as well applied to the structure successfully if you model the structure segmentally. Okay, but if the structure is modeled in full the way it is here, all of these parameters may not be applied effectively on the structure, and since they are not applied effectively on the structure, it simply means you will not have your results the way you are supposed to. Okay, so over here we have the material editing. So this is ACI code. So you can see in ACI code you will be seeing something like the concrete strengths C40, C400, and the rest of that. If I click in these provisions now, you have a series of concrete strengths here, but I use C400 for this project. Okay, this one. So if you get this template, you also have all of these set successfully. Okay, so you can click on apply to all members and then click on OK, and that will be applied successfully. If you don't want to apply to all members, you want to select different concrete strength for different member, you can also do that. This is steel strength. Okay, so if you click right there, you can see various steel strengths. I use SD40, the deform bar. Okay, select it, apply it to all other members just like this. So this is how it is. If you click in the rebar diameter options, you will notice that the label is D10, while for British and then concrete strength 410, you'll be seeing Y. Okay, for Euro code, you'll be seeing this labeling to be T, but for ACI code, you can see it is G that is being used to represent. All the areas are almost the same. Okay, the areas of the reinforcement are almost the same. Okay, for the both ACI code and the Euro code. All right, so you can get this selected, and this has been set successfully. Okay, this has been set successfully. So if you get this template, I believe you won't be bothering yourself setting all of this. You can just go through them, confirm them, and carry out your design and analysis successfully. All right, I click on the OK options, and also for the foundations, you can also carry out your foundation settings successfully. Click on OK options. All right, I believe all of this has been explained successfully. If, for instance, I want to remove the seismic parameters, how you remove the seismic parameters, you need to come to these provisions of project parameters. Click right there, and then click on this provision here. Once you click here, see the seismic option is being removed. So if you check here, it is still here. Once I click on OK options, you will see seismic parameters tab here again. So I do that right away. Click on OK options, just like this. You can see seismic parameter tab has been removed from here. All right. Okay. So if I come to project parameters again, all right, and then I click in these three dotted provisions, if you take me to the project, I'll be able to choose IBC, which is the International Building Code. This one for the seismic. Okay. Click on picked options. To pick it is now there. So once I click on OK, you will see it appears here. So this is how to navigate or to turn on and off seismic provisions in this project analysis dialog successfully. Click on OK, so you can see it right there. All right, so this is how you apply that. Click on closed successfully. All right, so this template is ACI code template, which has been set successfully. Okay, I've used it to complete this project. This project was actually carried out using pile foundations. All right, so I want to be showing you how you can use this template effectively. For you to use this template effectively, what you just need to do, you will just have to first of all you save this project as. So you come to these provisions, and then you go to save project as, this options. Okay, so once you click on these options, do you want to save changes to this? All right, you can say no for now. All right, and then click on this. Okay, give it another name. Maybe you just add 3 there, auto building design 3. Okay, so click on OK options. Give the program some seconds to be able to save the project successfully. So now the project is being saved just like this with that name. You can see it over here. So what you just have to do, you come to the story 13. You have to remove all of these stories up to story 1. Okay, so you will come to story 13, right click, and then click on remove stories. Once you click on remove story, click on yes options, you will notice that the story 13 is now off. You are not having 10. So select the you are not having 12. Select 12 again, right click on remove story, and yes options. Okay, so the 12 is being removed. Now we're now left with 11. So that is the process until you get to 1. Once you get to 1, what you will do here, expand this. by double clicking on that. Okay, so we select this. Now right click. What you are going to do is you are not going to remove the story, rather you are going to delete members in this story. Okay, so you use the option delete members in this story because at default Protastructure only has story 0 and 1 at default, so you wouldn't remove story 1. Okay, so once you must have removed all of the rest of the stories, coming to story 1, use delete member in story options. Okay, so once you click on this, you delete all the members in these stories. If there's any member left, you will just have to highlight all of it just like this. So once you get them highlighted like this, once you get them highlighted like this, just have to right click and click on delete to the rest of the members and as well as the objects you have in the interface. So once you are able to delete all the members, you will have something like this. So you have an empty template, ACI template, just like this. You have an empty ACI template, just like this. Okay, so I will also zip this in a folder, okay, and drop it in the description of this video so you can make use of it. Okay, so these are empty template folder in ACI code, a template, ACI template code. Okay, successfully, just like this. So you can see my story 1 and story 0 is now empty. Okay, the way it is. All right, so now if I want to bring in a design, a structure, maybe from AutoCAD, at first you have to save it to DSF, as we all know. Okay, or if you did not know, you can check in the descriptions of this video. There is a lesson that actually explains that. Okay, so I want to build a structure. You have to navigate to the building set out options. Okay, once you get there, come to DSS import. You click on DSS import. You have DSS import options just like this. So I want to be bringing in a design. Okay, so you have to select this reset layers. Okay, just like this, and then come to load load DSF. Okay, so once you click on load DSF, I want to bring in this duplex. Okay, this has been saved in DSF. Okay, DSF file. Okay, you can see this is an AutoCAD file, DSF. Okay, so once you select that, click on open. So once you click on open, you can see the parameters of that particular duplex. It consists of the grid layers and as well as the column layers. Click on the import options. So once you click on import options and then it's been imported successfully, you just have to click on the OK options. So you have this now. So with this, you now start your modeling, okay, successfully, which we will be doing in this subsequent lesson. We will carry out our modeling. If you check now, this grid line is not in line with this other ones. If you want to extend it, get it selected, right click, and then select this stretch axis. Okay, pick this point and take it up to here. All right, click. All right, to have it in line. So you can also edit this by getting all highlighted, right click and click on the property. All right, so in this property dialog, it will now help you to change the name accordingly by referencing what you are having here. By then, you should have to zoom this very closely so you can be able to see the letter successfully. All right, so we'll be making progress successfully into this particular code, as we'll be using it to carry out our building design in ACI code. So you can just get this template, okay, and then we make progress successfully. If you have any questions, you can drop it at the comment sections of this video, okay, and then don't forget to like and subscribe to the channel. I'll bring the lesson to a stop here. Bye for now and see you in the next lesson.